Yeah, hi everyone. Welcome to MyMax Academy. In this video, we'll continue with Chapter 1 Real Numbers from 10th Standard CBSE Mathematics. So we'll continue with Theorem 1.7 in page number 17. So page number 17, Theorem 1.7. Page number 17, Theorem 1.7. So what says is, let x is equal to p by q. X is equal to p by q be a rational number. Right? Now again, p and q are co-prime, which is not given, but it should be co-prime, such that the prime factorization of q is not of the form 2 power n 5 power m, where n and m are non-negative integers, then x has a decimal expansion which is non-terminating, but repeating, or repeating can also be called as recurring, So what this 1.7 says is Theorem 1.7. Suppose if x is in the form of p by q, where p and q are co-prime, which means if you simplify, writing x in the simplest fractional form, simplifying the fraction and getting the fraction into the lowest form, right? Be a rational number. X is equal to p by q, be a rational number, and p and q are co-prime. P and q are co-prime means you are cancelling out any common factors and you are writing x as in the simplest form of the fraction. At that time, if you try to find the factorization of q, prime factorization of q, the denominator, and suppose if it is not in this form of 2 power and 5 power m, then we can say that x has a decimal expansion which is non-terminating, repeating. It will not terminate, which means the decimal expansion of that number will not stop, but it will repeat. It is non-terminating and repeating, or it is non-terminating and recurring, which means the decimal part will not stop. It will be like this, 0.3333, like that it will go. This is called as non-terminating but repeating. 3 is repeating, but it will keep on going, 3 like that, it will keep on. So this is called as non-terminating but repeating. So if the q is not in the form, this word not is important. If q is not in this form of 2 power and 5 power m, then we can say x will have a non-terminating but repeating decimal expansion. Fine. So I'll give some examples. So example number, I'll give some examples. Suppose if we take the example as, suppose let's take x is equal to some examples I'm giving, so that you can understand this theorem. Right. So example is, suppose if x is equal to 4 by 70. Now we cannot say x is in this form. You have to first simplify. Whenever any fraction is given, you have to simplify. Now we need to check whether this will have a non-terminating but repeating decimal expansion. For that I am giving examples. So now we will simplify this. So 2 2s are 4, then this is 35. So it becomes 2 by 35, right? For 2, if I cancel by 2, it becomes 2 by 35. So now my x is 2 by 35. Now can we simplify this further? No, we cannot simplify. This is the simplest form, which means it is in this form, p by q, where p and q are co-prime. Right? Once you simplify and get it in the lowest form, In that lowest form, you have to check what is your P. That time you call this as P, this as Q. Not here. We don't call P as 4 and Q as 70. No, you have to first simplify. Now X is in the simplest form of the fraction. At that time, you should call the numerator as P and denominator as Q. Now what is our Q? We should focus only on Q. Q is the denominator. Q is what? 35. So 35 can be written as what? It can be written as, if you do the prime factorization for 35, 5 times, 7 times, 7 times, 1 times. 5 into 7. Is it in the form of 2 power n 5 power m? Does it have 2 and 5? No. 5 into 7. It should have only 2 or only 5 or only 2 and 5. But it has 5 and 7. So it is not in this form. So we'll say, therefore Q is not in the form of 2 power n 5 power m, 2 power n into 5 power m, where I can write here, where n comma n are non-negative integers, therefore by this theorem 1.7, we can say x is equal to, what is the given x? Given x is 4 by 70. 4 by 70 will have non-terminating repeating, and repeating decimal expansion. We'll have a non-terminating but repeating decimal expansion. So if you divide this if you divide by 35, suppose if you do the long division, suppose our normal division, suppose if I do here, if I divide 2 by 35, right? 2 does not go in 35. 2 does not go in 35, so 0. 0.20, 20 also doesn't go, again 0. Then get 200. 200 goes how many times? 1, 2, 74 times. Right? We get 140, no, 5 times. 5 5s are 25, 70, 175. Then 25. Then bring the 0 again. 250 goes how many times? 35 into 6, 7, let's try. 35 carry 3, 21, 24. So 245. 245. It goes 7 times. Right? Then this becomes 5. Then put 0 1 times. Then if I again divide, right, by 35, 1 times 35, you get 15. Right? Then again we put the 0, this 15. Again if I put the 0, it will go 4 times, 140. Right? Then I will get 10. 10 becomes 100. 100 goes how many times? 2 times, 70. Then remainder is 30. 300. 300 goes how many times? 8 times, 40, 4, 28. We get 20 again. We get 20 again. We get 20 again. Then again it will become 200 and this will become 175. So it will continue. The same part will continue again. So which means it will become again 5, 7, 1, 4, 2, 8, like that will go. So the decimal equivalence of this will become, right? Suppose if you divide, you will get it as like this: 0.0571428571428, like that. It will keep on going. But this is repeating. 571428, 571428. That will keep on repeating. Right? So this you need not even divide like this. But without even dividing, we can say that it will have a non-terminating but repeating decimal expansion, because Q is not in the form of 2 power n into 5 power m. 2 power n into 5 power m. Clear? So we'll do one more. Let's do one more. Suppose if x is equal to, one more example, say 10 by 48. Next example, x is equal to 10 by 48. Then we will have to simplify this. If I simplify this, 2 5s are 10, 2 into 24. So you get 5 by 24. We get 5 by 24. Now let's divide. Now we need not divide this. Now we need to just, without doing actual division, we have to check whether it will have a non-terminating but repeating decimal expansion. For that, now we have simplified. Right? We cannot simplify this further, which means, what is my x? My x is now 5 by 24, which is in the form of p by q. Now my p is 5, q is 24, and they are co-prime. Co-prime means no number will divide both 5 and 24, except 1. 1 is the only number which will divide 5 and 24. No other number will divide. Right? So my p is 5, q is 24. Now we should focus on q. Once we get it in the simplest form of the fraction, after converting that, then we should go and take the denominator, which is q. Q is what? 24. Now 24 can be written as what? In terms of powers of, if you try to write the prime factorization for that, right? So I can write it here. Right? So 24, if I do, 2s are, 12s are, 2, 4, 6 are, 2, 3s are, 3, 1s are. So you get 2 into 2 into 2 into 3. So my q becomes 2 cube into 3. 2 cube into 3 is 24. 2 cube is 8. 8 3s are 24. Now q is in this form. 2 power n, 5 power m. No. It has 3. It should have only 2 and 5. Or it can have only 2 or it can have only 5. Then we can say it is in this form. But here it is not in this form. Q is not in the form of this. So we'll say, therefore q is not of the form 2 power n, 5 power m, where n comma m are non-negative integers. So therefore we can say, therefore x is equal to 10 by 48 will have non-terminating and repeating decimal expansion. So we can say that it will not terminate. The decimal will not stop. It will be non-terminating, but it will be repeating. So that is why, no, as per this, since q is not in this form, not of the form, so it will not have a terminating decimal expansion, or it will have a non-terminating but repeating decimal expansion, because q is not in the form. If it is q is in this form, then it will have a terminating decimal expansion. If q is not in this form of 2 power n, 5 power m, then q will have a non-terminating but repeating or recurring decimal expansion. Fine. Now we will go to exercise 1.4. Fine. We'll do the problems in exercise 1.4. So let me erase this. Now what we have next is exercise 1.4 in page number 17. Same page number. So page number 17. Exercise 1.4. So what it says is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating decimal expansion. We have to just looking at, we have to check without actually dividing. We should not do the actual division like this. Without that, we have to say whether the given fractions in question number 1, whether they will have a terminating decimal expansion or it will have a non-terminating repeating decimal expansion. Also, there is a second problem. I will try to combine both the first and second problem together, because the second problem is related to the first problem. So second question in your textbook, which is in page number 18, it says, write down the decimal expansion of those rational number in question 1 which have terminating decimal expansion. Which have terminating decimal expansion. The second question says, whatever x or whatever fraction in the question 1 has terminating decimal expansion, for those we have to find the decimal equivalent of those fractions. For those we have to write the decimal expansion of those numbers, those fractions in question 1 which have terminating decimal expansion. Non-terminating we need not do. So there are two things that we should check. First we will check whether it has a terminating decimal expansion or non-terminating but repeating. Suppose if it has a terminating decimal expansion, then we should find the decimal expansion of that number without actually dividing. So we have a way to find this without actually dividing. Fine. So we will do exercise 1.4. I'll do the first problem. So first problem, first subdivision. So what the question is? The question is, the given number is 13 by 3125. 13 by 3125. So this is our x. 13 by 3125. Now we should tell whether it has a terminating decimal expansion or non-terminating repeating decimal expansion. Right? So for that, what do we do? What we do is whenever a fraction is given, express them, both the numerator and denominator, in the form of prime factors. We have to simplify this. You have to simplify both. Right? Can we divide this by 13? We have to simplify this first. So before simplifying, what I would say is, let's convert the given numbers, the numerator and denominator, as prime factors. So which means 13 can be written as only 13 only. By 3125 can be written as what? If you do the prime factorization, it goes in 5, 6 times, 2 times, 5 times, again 5, 1, 2, 5, again 5, 25, again 5, 5, again 5, 1. So this can be written as 5 power 5. 1, 2, 3, 4, 5. Now we cannot cancel anything because this is 13 and this is 5 power 5. We cannot cancel anything. So this is in the simplest form or simplified form or the reduced form of the fraction. If there is anything that we can cut or cancel out, which is present in both numerator and denominator, any common factor we can cut, but there is no common factor. Here you have 13, here you have 5. There is nothing common. So which means at that time this is your P by Q. This is your P by Q. Now we should check what is Q. My Q is equal to what? 5 power 5. Q is equal to 5 power 5. We should not take this as Q. Right? But here this is the simplest form. So we can take this also as Q, which is 5 power 5. But generally after checking whether we can cancel anything or not, if you can cancel, you have to cancel and then take the simplified form of the fraction as P by Q. Then Q is 5 power 5. So we can say, so therefore Q can be written as what? 2 power 0 into 5 power 5. I can write it in the form. So therefore what we can say? Therefore Q is of the form, Q has taken the form of 2 power n into 5 power m, where n comma m are non-negative integers. So Q is in which form? Q is in this form. You can have 2 power 0. See, 5 power 5 means I can write that as 2 power 0 into 5 power 5 because 2 power 0 is 1. So I am getting this Q in this form. So the n is what? N is 0, m is 5, and they are non-negative. It cannot be negative. It can be 0 or positive, but the power should not be negative, and which is in the form. So therefore what we can say by theorem 1.6, by theorem 1.6 in your textbook in page number 16, right? Q is in this form. Whenever Q is in this form, we can say therefore x is equal to 13 by 3125 will have terminating decimal expansion. So it has a terminating decimal expansion. It is not non-terminating and repeating, because if it is not in the form, then it will be non-terminating. If it is in the form, then it will be terminating. See here Q is in this form. Q is of the form 2 power n, 5 power m. Therefore it will have a terminating decimal expansion. Now we will do the second question also. Second question's first part. Second question also will do for this problem, for the same problem, right? So what we have to do, the second problem says that if whenever, right, the second problem in the textbook is in page number 18, it says write down the decimal expansion of those rational number in question 1 which have terminating decimal expansion. So whenever you get a terminating decimal expansion, you have to write the decimal expansion of that, which means we should convert this 13 by 3125 as decimals in the decimal. We have to convert the fraction into decimal because it has a terminating decimal expansion. In that case, we have to convert, but not by actually dividing using our normal division, without dividing. So how do we do that? Now this is what? So let's take this. So x is what? 13 by 3125. Since it is having terminating decimal expansion, we are trying to convert the fraction into decimal. If not, we will stop. That I will do it in the next problem. I'll explain. Now this is what? This is actually 13 by 5 power 5. Now we are going to convert this into decimal without actually dividing. Now whenever you get it in this form, because 5 power 5 is 3125 is 5 power 5. Now what we should do is we should try to get in the denominator. You have 5 power 5. We should try to get 2 power 5. If it is 5 power 5, we should get 2 also with the same power as 5. So which means we should get it as 2 power 5. So I will multiply and divide by 2 power 5 by 2 power 5. Multiply the denominator and numerator with 2 power 5, because if the denominator is 5 power 5, I should get 2 power 5 also. Why we are doing this? We are going to convert this fraction into decimal without actually performing the division. So then it will become what? So what is 2 power 5 into 13? 2 power 5 is 32. What is 32 into 13? So 32 into 13. 32 into 13 is what? 13 2s are 26. Carry 2, 13 3s are 39, 41. Right? 26, 6, carry 2, 13 3s are 39, 39 plus 2 is 41. So you will get 416 by, now if you multiply this, 2 power 5, this will become 5 into 2 whole power 5. 5 power 5 into 2 power 5 is what? 5 into 2 whole power 5. So it will become 416 by 10 power 5. 5 2s are 10. So this will become 416 by 5 zeros I should put. 10 power 5 means I should have 5 zeros. So this will become, now if you divide this, it will be 0.00416. What is the value of that? 0.00416. Because you can divide, no? You can divide by 10,000, then the decimal will move. I hope you know how to divide this. Fine. So now, next problem. So what we have done here is, we have first to check whether it has a terminating decimal expansion. If it has a terminating decimal expansion, we have converted this fraction into decimal without actually dividing. If you divide also normally, if you divide like this, 13 and 3125, and if you do this, you will get this 0.00416. Right? Now let's take the next example, next problem. So in the first problem, second sub problem. Fine. So what it is? So what we have now is 17 by 8. 17 by 8. That is my x. My x is equal to 17 by 8. Now what we'll do? Can we simplify this further? No. 17 by 8 I cannot simplify. It is already in the simplest form. Then my x is equal to 17 by 8 is of the form p by q. The first step is we need to simplify, right? Or you can write it as, you can write this as I said, we'll write the 17 and 8 can be written as 2 power 3. 8 can be written as 2 power 3. 17 can be written as 17 only because 17 is a prime number. Now anything is getting cancelled? No. When it is not getting cancelled, then at that time we should call that as p by q. Now what is my q? Q is 2 power 3. Now that can be written as what? 2 power 3 can be written as 2 power 3 into 5 power 0. So therefore q is what form? Q is of the form 2 power n into 5 power m, where n comma m are non-negative integers. Non-negative integers, and where n and m are non-negative integers. So therefore what we can say by theorem 1.6, therefore x is equal to 17 by 8 will have terminating decimal expansion. Decimal expansion, we can say that it will have a terminating decimal expansion. So this is where the question 1 ends. Question number 1, second part ends here. Now we will do the second questions also, because the second question in the textbook says that whenever the given number in the question 1 has a terminating decimal expansion, we should find the decimal expansion of that, which means we should convert that number into decimal. So let's try to convert this. Now what is x? So I am doing the second part. Second question, second part. This is second question, first part. For this first problem, we are doing the second question also. Why we are going for second question? Whenever it has a terminating decimal expansion, we should do. Now x is equal to what? 17 by 8. That can be written as 17 by 2 cube. The simplified or the simplest form I have taken. Now my x is 17 by 2 cube. Now here I should get 5 cube. You have 2 cube, I should get 5 cube also, which means I should multiply and divide by 5 cube. So why we are doing this process? Because we want to convert this 17 by 8 into decimal without actually dividing. Now what happens? My x becomes what? 5 cube into 17. That is 17 into 5 cube is 125. Why? Here 2 cube into 5 cube will become 10 cube. Right? Or you can write it as 2 into 5 the whole cube. So don't convert this into 8 and this into 125. You can convert and multiply, you will get the same value, but it's better to keep it as 2 into 5 whole power 3, because it will become 10 power 3. That is easy. So this is equal to, x is equal to, now what is 17 into 125? Let's do that. So 125 into 17. 17 5s are 85. 8, 17 2s are 34. 34 plus 8 is 42. Carry 4. 17 1s are 17, 21. You get 2125. So you get 2125 by 2 5s are 10, 10 cube, which means 2125 by 1000. So what do we get? If you divide, you will get 2.125. What is the decimal expansion of 17 by 8 is 2.125. Clear how to do this? Right? Now let's go to the next problem. I will do the next problem. In the first problem, third sub problem. Right? So in the first problem, I'll do the third sub problem, which is third sub problem. So what it is? The question is 64 by 455. X is equal to 64 by 455. Now first step, what we should do? We should convert the given two numbers into prime factorization form. Right? So 64 can be written as, if you do for 64, if you do with this 32, 2, 16, 2, 8, 2, 4, 2, 2, 2, 1. 1, 2, 3, 4, 5, 6 2's. So your x becomes 64 can be written as 2 power 6 by 455. 455, let's do prime factorization. So 591, right? 9, so then it goes in 7, 13 times. Then 13, 1 times. Now this becomes 5 into 7 into 13. Now can we simplify anything? Anything getting cancelled? No, it has only 2, there is no 2 here. So you cannot cancel. So this is already in the simplified form. The moment you cannot cancel further, at that time you should call this as P by Q. P by Q. Fine. Now Q is what? Now Q is what? Q is 5 into 7 into 13. This one. So therefore, we'll say therefore Q is not of the form. It is not in the form of, Q is not of the form 2 power n into 5 power m, where n comma m are non-negative integers. Non-negative integer. So q is not in the form. Q is what? 5 into 7 into 13. But q should have only 2 and 5. But q is not in the form. That's why we say q is not of the form. 2 power m, it is not in the form. This is not like 2 power n into 5 power n. It's not like 2 power something into 5 power something. So therefore, we can say by theorem 1.7, therefore we can say x is equal to 64 by 455 will have what kind of decimal expansion? Non-terminating but repeating. Non-terminating, repeating decimal expansion. Decimal expansion. Clear? Non-terminating but repeating. Non-terminating and repeating decimal expansion. So it will have a non-terminating repeating decimal expansion. So we need not try to do like this and try to get into the decimal equivalent of that. What we need not convert this into decimal like this, how we did the last problem, because it is having non-terminating and repeating. But the question 2 says only if it has a terminating decimal expansion. See, here we did it because it has a terminating decimal expansion. So we converted into the decimal. But here it is non-terminating and repeating decimal expansion. Non-terminating and repeating decimal expansion. So we need not find this because they have said only for the cases where it is terminating, find the decimal equivalent. If it is non-terminating, we need not do the second problem for this. The second problem is applicable only wherever it is terminating decimal expansion, we have to find the decimal expansion of that. So if it is non-terminating and repeating, then we need not do the second questions part. Like second question part we need not do. Now we will go to the next problem in first. So you can try the fourth problem, right? So maybe I will say you can try the fourth problem as homework. Fifth also you can try as homework. Sixth also, sixth I will do. Sixth problem, I will do the sixth problem. And so sixth problem. So in first you do the fourth and fifth as homework. You try this. If you have any question, you can WhatsApp me. I will try to explain as much as possible. Fine. So give me 1 second. My laptop is running out of charge. Charging this. Okay. Now it's fine. Okay. So now, so fourth in the first problem, fourth and fifth sub problem, you try as homework. I will do the sixth one. The sixth one is I'll write it here. In first problem, sixth sub problem. So x equal to, what is the sixth one? X is equal to 23 by 2 power 3 5 power 2. 23 by 2 power 3 5 power 2. Now a 23 is a prime number, so it is already in the prime factorization form. Denominator also they have given it as a 2 cube into 5 square. Now is there anything that is getting cancelled? No, because it is 23, here we have 2 and 5, we cannot cancel. So this means it is already in the simplified form. So which means my x equal to 23 by 2 cube into 5 square is becoming p by q. So what is my q? Q is equal to 2 power 3 into 5 power 2. So therefore what? Q is in which form? Q is in that form. So therefore q is of the form 2 power 3 into 5 power 2. So therefore we can say therefore x is equal to 23 by 2 cube into 5 square will have terminating decimal expansion. Right? Because q is of the form. I missed the word form. Q is of the form this, therefore it will have a terminating decimal expansion. So if it is a terminating decimal expansion, then we should do the second problem also. right? So since it has a terminating decimal expansion, we have to find the decimal equivalent of that, or the decimal expansion of that. So how do we do this? Now x is, so in the sixth problem, yes, x is what? X is 23 by 2 power 3 into 5 power 2. Now whenever we need to convert, this is 23, sorry, 23. Whenever we need to convert the fraction into decimal without actually dividing, then what we have to do is, we will have to we have to have the same powers for 2 and 5. The power for 2 is 3 and power for 5 is 2. You should get the same powers for 2 and 5. So which means I need 2 power 3, means here I should get 5 power 3, but I have only 5 power 2, which means I need one more 5 to make this 5 power 2 as 5 power 3. So which means you will multiply and divide by 5. So that the 2 power and 5 power, both of them are same. So which means my x will become 23 into 5 by 2 power 3 into 5 power 3, because 5 power 2 into 5 is 5 power 3. Now this will become x is equal to 23 into 5 is 115 by 2 cube into 5 cube is 10 cube. Right? So this will become, if you convert this, it will become 115 by 1000. So which is 0.115. 0.115. So now we have converted that into decimal expansion. We have found the decimal expansion for that. Clear? We have found the decimal expansion for that. Clear? 0.115. Fine. So now let's so I will say you can try the remaining problem as homework, right? So you can do in the first problem, try the 7th problem, 8th problem, 9th problem, and I think you have 10 problems, 10th problem. All these as homework. Similarly, same way you have to do. Fine. You can try these, and if you have any queries, please WhatsApp me and I will try to help you as much as possible. And this is my WhatsApp number, 98840360777. I'll try to answer your questions. So these you can try as homework, HW, homework. Try as homework. Fine. So I will go to the third question, because second question we have covered along with the first question. We have done the second question also. I'll go to the third question. So third question in exercise 1.4 is, third question, page number 18 in your textbook, exercise 1.4, third question. Third question is very simple, easy. It says the following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? What can you say about the prime factors of q? So first the numbers are given. We have to verify whether, we have to check whether it is rational or irrational. Whether it has rational or irrational. Suppose if it is rational, then we should say it can be expressed in the form of fraction. But what can we talk about the prime factors of q, the denominator? That is the question. So what I will do is, let's take the first question. In first question, what is that? 43.123456789. So this is a question. Now if you observe whether it is rational or irrational, first we should find. Now I had explained in my previous video what is a rational number, what is an irrational number and all that. Now to decide whether it's a rational number or irrational number, we have to check the decimal part. Decimal part stops. It does not go. The moment the decimal part or the decimal expansion stops, which means decimal expansion terminates. So here we'll say the decimal expansion terminates. So the decimal expansion terminates, then it is a rational number. Therefore 43.123456789 is a is a rational number. Now if it is a rational number, now we need to talk about what can we say about the prime factors of q, which means I can write 43.123456789 equal to p by q. You can write it in the form of p by q because it is a rational number. Now what can we talk about? You need not convert this into fraction. You can say it will be in the form of p by q, but they are asking what can you talk about the prime factors of q, which means what can we talk about the prime factors of q? Since it is having a terminating decimal expansion, therefore by our theorem 1.5 in your textbook, page number 16, theorem 1.5, whenever x has a terminating decimal expansion, then q will be of the form 2 power m into 5 power n. So we can say the prime factors of, or we'll say since the decimal expansion terminates the prime factors of q will be of the form 2 power n into 5 power m, where n comma n are non-negative integers. Clear? So first it is a rational number because it is having the decimal expansion terminates, therefore it is a rational number, which means I can write it in the form of p by q. But what can I talk about the prime factors of q? Prime factors of q will be of the form 2 power n to 5 power n because the decimal expansion terminates. As per the theorem 1.5 in your textbook, page number 16, if the decimal expansion terminates, then or if the decimal expansion terminates, then q will be of the form 2 power n into 5 power n. Right? Now the second question is what? Sorry, in third second part, what it is? 0.12, 012, 0012, 00012, like that it goes on. Now if you observe this, suppose if I call as x, suppose this number, right? So here the decimal expansion is what? The decimal expansion is not stopping, it is going dot dot dot, means non-terminating. Is it repeating? Any number is repeating. It is 1 2, it is 0 1 2, 0 0 1 2. So nothing is repeating. See, if it is repeating means if I have suppose 0 1 2, I should have 0 1 2, 0 1 2, 0 1 2, like that. If I have 1 2 1 2 1 2 1 2 should come. Or if it is 0 0 1 2, I should have 0 0 1 2, but I have 0 0 0 1 2. So it's not repeating also. So the decimal expansion is non-terminating and non-repeating. Therefore, what we can say? Therefore, it is an irrational number. It is an irrational number. This is an irrational number because the decimal expansion is non-terminating and non-repeating or non-recurring. Therefore, it is an irrational number. This is an irrational number. If it is an irrational number, we need not talk about this form 2 power n, 5 power n. This is applicable only for rational numbers. Only if it is a rational number, they say that, right? If they are rational and of the form p by q, then we need to comment about what are the prime factors of q. What can we say about the prime factors of q? But if it is irrational, we need not even talk about it. Right? So here it stops. If it is irrational, we need not explain this. Only for rational, we need to talk about this. Right? Now the third part. So in the third part, right? So what it is? That is 43 point. The number is 43.12345678 bar. The moment say the bar, it means it is like this. 43.12345678 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 dot 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 dot. Which means that is the meaning of this. Bar means this set is repeating and it is non-terminating. So which means what we can say, the decimal expansion is what? Is non-terminating and repeating. So if the decimal part is non-terminating and repeating, then also it is a rational number. If it is non-terminating and non-repeating, then it is irrational. So it is non-terminating but repeating. Therefore, the given number is rational. Given number is rational, which means it is a rational number. Whenever it is a rational number, then I can write the given number 43.123456789 bar. It can be written in the form of P by Q. Whenever it is a rational number, we can write that in the form of P by Q. Now, what can we talk about the prime factors of Q? Now, it is having what type of decimal expansion? Non-terminating and repeating. Whenever it is a non-terminating but repeating decimal expansion, right? Then as per Theorem 1.7, we can say, right? So whenever it is having a non-terminating and repeating decimal expansion, then we can say the prime factors of Q, right? We will say, since the decimal expansion is non-terminating and repeating, since the decimal expansion is non-terminating and repeating, therefore the prime factors of Q, is not of the form 2 power n into 5 power m. We can say it is not of the form 2 power n into 5 power n, where n comma n are non-negative integers. So what it means? So since the decimal expansion is non-terminating and repeating, so therefore the prime factors of Q, if I convert this in the form of P by Q, they are not asking you to convert in the form of P by Q. Suppose if it becomes in the form of P by Q, then my denominator Q will be not in the form of 2 power n into 5 power n, because it is having the decimal expansion is non-terminating and repeating. For a rational number, if it is non-terminating and repeating, then the Q, the denominator, if you write that as a P by Q form, then Q will be not of the form of 2 power n into 5 power n, because it is having non-terminating and repeating decimal expansion. Fine. So with this, we completed this chapter, and you can watch my next video for the second chapter, which is polynomials. So thank you for watching. If you have any queries, you can WhatsApp me. I will try to reply as much as possible. Thank you for watching. You can watch my next video for the next chapter, which is polynomial, which is second chapter in your textbook. Thank you. See you in the next video.